All right, folks, it's Bass Action back in action here. We are going to go through two examples in this video, one for writing the equation of a rational function based on a graph, and the other writing the equation for a polynomial function based on a graph. Now, there are three pictures in this on this page. We're actually only going to do two of these. The last one is a more advanced example, and I'm going to save that one for class. So let's start with our rational function graph up here, and we're just going to think backwards here in terms of where we found all of our information when we were trying to create a graph, and we're just going to kind of go backwards from that concept to create the equation itself. So when we were looking for or finding x-intercepts before, okay, we would find our x-intercepts consistently by looking at the numerator of our rational function. So when we look at our graph, we know that our x-intercepts from our graph are going to need to go into the numerator of whatever fraction we end up creating here. Now, when I look at my graph right here, what I can see is that my x-intercept, also happens to be my y-intercept, is right here at 0, 0, but I also want to notice that this is a touch and turn. So that should tell me that I'm going to need a double. So when I go to set up my function, I can go ahead and say x minus 0. Now, of course, we don't need to write the minus 0 and an x minus 0, but it's nice for us just as we're thinking along that it would be x minus whatever you knew the 0 to be. So we're going to have our x minus 0, that's going to create that. Then we're going to take a look at my vertical asymptotes. And of course, vertical asymptotes, we know where our function is undefined. So I can see that I've got two vertical asymptotes here. So those vertical asymptotes expressions should go in the denominator, thus creating the undefined values. So I have an asymptote at a -3 and I have an asymptote at a +3. So I'm going to say x minus 3 and an x plus 3. That's going to create both of those vertical asymptotes. Then, so in fact, if we want to give ourselves some little lines here where those are coming from, then the next thing that we want to look at is our horizontal asymptote, and we can see that we have a horizontal asymptote here at y equals -5. Now, at y equals -5, since we have that there, we know that this should have been a SAM. The degree in the numerator should have been the degree in the denominator. And sure enough, my degree in my numerator is 2, my degree in my denominator is 2, so this is already set up as a nice SAM, so all I need to do is to create a leading coefficient of a -5. So I'm just going to, for simplicity, but just put a -5 here. Suppose if you wanted to be really complicated, you could say, you know, -10 over 2 or something to create it, but just put that -5 there. Now, if we think we're done, we can go ahead and set this equal to r of x so that we actually have a nice actual function. And then we're going to do this last little bit and we're going to check the y-intercept. Sometimes, as we would have in this example B that I'm not going to do in this video, you've got to do a little bit more finagling to get that to work. So we're going to check our y-intercept and make sure our function is in fact correct. So we're going to find r of 0 based on the function we have, and we would have a -5. Of course, x minus 0 is 0, and x minus 0 is 0, and that's going to be over a -3 and a +3. And of course, 0 divided by anything is 0, so this checks out, and our final answer is good. Okay? Now, for our polynomial functions, we're going to take all those concepts from our polynomial basics and we're going to work backwards. This is really not much different than creating the graphs or the equations for a quadratic. The important thing to know, and I'm just going to make a little sketch here, the important thing to know is that if I have some function that has zeros at some values, I could make a graph that goes through that polynomial function that looks like this, or I could make one that goes way up here and down here and looks like this, or I could make one that comes up and maybe comes in the middle. So there are many, many ways to create a function that has the same x-intercepts. So when we're looking at our graphs, we don't want to just focus on these x-intercepts that we have here, but we also will need to choose a very specific value that is easily read from the graph. Now, I will usually point it out for you so it's really clear. This one looks like we have a nice clear y-intercept, but we actually do not because of the way this graph exported. So we're going to actually choose this point right here, this point at 4, 5. Okay, so it is important that you find a specific point so that you actually get the full, correct, accurate graph. Now, when I look at this graph here, I can see that this one right here is a double. So when we set up our polynomial function, we're going to make sure that we indicate that as a double. So we're going to just find our zeros. So we're going to say our y equals, and we're going to fill in this a. We've got to have that a, and we're going to use that with our very specific point here in a moment. And I can see that I have a 0 here at -2, so I'm going to set that up as an x plus 2. And then I have my 0 there at 3, but that one was our double. So when we set this up, we're going to say x minus 3, and then we're going to give it its exponent of 2. Now we can go ahead and we can fill in this nice ordered pair that we know for as our xy pair, and that's going to give us a 5 here. I still don't know a, that's the point of this whole thing, and we're going to fill in 4 plus 2 and 4 minus 3, quantity squared, don't lose that squared, and now we're just going to keep solving for a, so I'm going to have 5, an a, and a 6, and 4 minus 3 is just 1, so it doesn't matter what I get when I square it. So my a value is 5/6. So the final answer for my actual polynomial is y equals 5/6, x plus 2, and x minus 3 quantity squared. Now, if the directions said to simplify, you would actually need to FOIL this whole thing out and expand everything. But oftentimes I don't actually ask you to do that, especially when we have a weird leading coefficient. And that's all that we've got on that one.